So today we're gonna be solving another problem from the MIT integration bit. This time we're gonna be solving a problem from the 2019 qualifier exam for the competition. This looks like this. This is the integral, a indefinite integral of x plus 1 divided by x multiplied by x plus the natural log of x is gonna be all with respect to x. So how do I want to solve this problem? Well, first of all, this fraction looks just about messy, but the thing that messes around here the most is this x in the denominator. I really do not like this one. So maybe I could get rid of it somehow. Well, I definitely can. So I'm just gonna rewrite my integral as the integral. Oh no, it's awful. The integral is even more awful, but yeah. Crap. So, as the integral of x plus 1 divided by x multiplied by x plus the natural log of x, and now I'm just gonna divide and multiply the entire integrand by 1 over x, just like this. I'm gonna write a dx right here. And so what I did now is I just divided out the x from the numerator and the denominator, so I'm just gonna be left with 1 plus 1 over x all over x plus the natural log of x, because the x from the denominator disappeared just as I wanted it to. And now, well, this thing looks solvable right now. I mean, I could just kind of nicely go on and set myself a u equal to x plus the natural log of x. I would get my du equal to 1 plus 1 over x dx, and pretty neatly, this is my du right here. So, well, I actually do have my du in the integral. I don't have to multiply through by any kind of a function of x. So I'm just gonna parenthesize it like a matrix or something, and I'm just gonna plug this u sub into my integral question. I'm gonna get the integral of 1 over u with respect to u, 1 over u with respect to u. But this thing is just the natural log of the absolute value of u plus a constant. Now just kind of plug in my u sub back into the final result. I'm gonna get this all equal to the natural log of x plus the natural log of x, and then all plus a constant. Hope you guys enjoyed it and see you in the next one. Bye.